system. And again, most, if not all of this should be review. Okay, so here are the 5 things that we're going to go through briefly. All right, so remember with the main branches of the nervous system, we've got the autonomic and we've got the somatic. The autonomic controls smooth muscle, cardiac muscle, endocrine glands, whereas the somatic nervous system controls skeletal muscle. We can also think of these in terms of autonomic is involuntary, the somatic is voluntary. Okay, now in order for things to happen inside of a cell, we have to change membrane potential. Okay, and so there's a bunch of things that establish membrane potential. All right, and so there are actually 4 primary things. And so I'm trying to find my little key here. Okay, so we've got proteins. Okay, proteins are negatively charged, and so they make membrane potential more negative. Okay, that's a negative sign. We've got the sodium leak channels. Sodium makes it positive because what happens is lots of sodium outside, we bring sodium inside, so we're bringing positive charge inside the cell. Okay, that makes membrane potential more positive. Potassium leak channels are the opposite. So we have potassium which leaves, and that makes membrane potential more negative because we're losing positive charge. And then we've got the sodium potassium ATPase pump, and I've lost my little thing again. There we go. So we'll just keep, and we'll circle it here. Okay, this makes membrane potential more negative. Sorry that it looks like I'm just drawing a line back and forth, but that's negative. So 3 sodium are pumped out, 2 potassium are pumped in. Those 4 things establish membrane potential in a neuron. And so when this membrane potential changes, and especially if it increases to reach threshold, so we go from this -70 up to this, so we start here at -70 and we go up to -55, an action potential occurs. And so I'm going to briefly go through these 7 steps. So 1, we're at resting potential, and that resting potential, I'm going to go back a slide, is an equilibrium point based off these 4 things: proteins, the potassium leak channels, the sodium leak channels, and the pump. Okay, so then we have some sort of stimulus. So we open up some door or gate that lets some ion in or out, but causes membrane potential to go from -70 to -55. Once we hit threshold, the sodium activation gates open quickly, the potassium gates open slowly, which means we have a lot more sodium going into the cell than potassium leaving, so this is depolarization or becoming more negative. At about +30, the sodium inactivation gate closes, and it was already open at resting potential. And so we're inactivating depolarization, and so that sodium influx through those voltage-gated channels stops. Leak channels, remember there's leak channels, those are constantly open, so sodium's still going in, but when we open these voltage-gated channels, a lot more sodium goes in. All right, and so during 6, we have repolarization, or returning to our original negative state, and that's because potassium is leaving the cell through these gates that open slowly. At the end of repolarization, everything flips, and so that activation gate closes quickly, the potassium gate closes slowly, and the inactivation gate opens. Okay, now because that potassium gate closes slowly, we have potassium efflux, or we have potassium efflux continue, and so we hyperpolarize or become more negative than normal. Once that gate finally closes, really where we're right around here, what happens is we return to resting potential because potassium is being pulled back in by those negatively charged proteins. Okay, I know this is a lot and you probably forgot about this, but that's kind of how it is. All right, so then let's talk a little bit about the sympathetic and parasympathetic nervous systems. The sympathetic nervous system is a fight or flight. So think about it. I see a bear. What's going to happen physiologically? Okay, not I'm going to run away or whatever, but what happens, what changes physiologically? So my heart rate will go up, my blood pressure go up. I'm going to shift blood to my skeletal muscle into my heart. So if I do run, I'm ready to go. So this can happen because you see a bear or because you're ready to exercise, run, swim, jump, whatever. Conversely, we have the parasympathetic side. So this is a rest and digest system. Okay, this essentially does the opposite of the sympathetic nervous system. Everything slows down. Blood flow goes to my intestines, to what we call my splanchnic region, just kind of the core. Okay, I'm not going to my skeletal muscle. I'm just taking it easy. All right. Now, the sympathetic and parasympathetic experience what's called dual innervation. So both branches of the autonomic nervous system go to most organs, such as the heart and lungs, among others. They're always active, but they're not active to the same extent. And we refer to this level of activity as tone. Okay, and so we've got, trying to show you this here with this little slider. So both sliders are on, but one is a little more on than the other, right? And so generally what happens is that, let's just say this is a sympathetic nervous system. So if this one goes up, this one will go down. Now that's not always the case, but generally it is. The last thing I want to talk about are muscle spindles and Golgi tendon organs. And we'll get into this more in the second unit, but I want to remind you about muscle spindles because we talked about it in PE 220. Muscle spindles are a type of mechanoreceptor that are deep inside of a muscle, and all they do is they monitor the length or how fast the length is changing in a muscle. They don't sense the tension, they don't sense the contraction, they're just primarily concerned with length. And when they lengthen, or when they lengthen rapidly, they send lots of signals to the central nervous system going, hey, this muscle is getting really long. Ultimately, what happens is when the muscle is lengthening, especially if it's lengthening quickly, it causes muscle contraction. Okay, so it activates the muscle to shorten it to prevent like muscle tears. On the other side, we have something called a Golgi tendon organ. And many of you might not have heard about this. We don't talk about it in 220 these days. But it actually senses tension or the rate of change in tension. It doesn't sense length. Okay? And so this is activated when you have a high amount of muscle tension. Okay? But it has the opposite effect. And so instead of causing muscle contraction, it prevents muscle contraction. And so your muscle relaxes when we activate our Golgi tendon organs. Okay? And notice that they're actually in the tendon, not the muscle. And so that is where we're going to end our nervous system review.